But the general problem with the strategic fund allocation in China is it is dominated by technocrats who have a vision for what they want, and that vision is pretty focused on making sure there is leading edge manufacturing in China. But at the end of the day, all the money in the world won't get them there. And prioritizing more fabs that are saying they're pursuing leading edge manufacturing really does not represent a good use of funds.
China's chip dreams. That's hard to say. China's chip dreams and what the U.S. should do about them. John Verwey, formerly of Commerce's BIS, the USITC, and USTR, and recently just left government and was last spotted skiing in Washington State, joining China Talk today. John, welcome to the show.
Thank you for having me.
So, John, where does China sit today in the global semiconductor value chain?
It is struggling, in a word. If you think about the global value chain for semiconductors is generally consisting of 3 steps: design, fabrication, and assembly, test, and packaging, which is bundled into the 3rd step. China's performance is a mixed bag. There are definitely some signs of hope in each of those 3 steps that I just mentioned. But in general, its progress up the global value chain is not happening as fast as it would like or as broadly as it would. It's just not seeing the success that it had hoped for in lots of the industrial plans where it articulated its goals for this industry and its industry's domestic progress.
So let's take it all the way back to 1956, which is where you start the clock on China's chip dreams. What was the vision throughout the Mao years and coming up to the end of the century from a policy planning perspective within the Chinese government?
So I generally break it down into a few multi-decade periods. Beginning in 1956 and concluding in 1990 is one chunk of time in which China's industrial efforts with respect to semiconductors followed a certain logic and plan. And then a second period from 1990 to 2002, another from 2002 to 2014, and then 2014 to present. So before I get started with each of those periods, I should definitely direct any interested listeners to the PhD dissertations of Susan Mays and Doug Fuller. I think Doug actually appeared on your show previously, but the two of them really wrote the history of the Chinese chip industry from the mid-1950s to present and did the original research. And a lot of what I will summarize here is derived from their work. With that said, the period from 1956 to 1990 was all about state-led planning with a heavy emphasis on indigenous innovation. And in practice, what that meant is the Chinese government decided they wanted to make chips, and they ran a series of state-run labs that conducted research and development with respect to materials, design, fabrication, all aspects of the chip process. And then they also stood up state-owned factories. And in those factories, they would manufacture the chips that they thought were both going to be important from economic and national security perspectives. The result of that effort was several decades where they didn't really make progress at the same time that the rest of the international industry was making tremendous progress. And this was evidenced in a lot of different performance metrics, but generally speaking, when researchers would look into the state of the Chinese industry in the 70s and 80s, they would find that the factories were producing chips that were 10 to 15 years behind the leading edge at that time. And they would also find that the quality of the manufacturing process was distinctly lacking. And these factories were getting yields on their wafers as low as 20 to 40%. And obviously industry standard is much more like 80 to 90%, and ideally much more than that. And low yield, of course, is correlated with a limited number of functioning chips and therefore a lot of wasted money. So that's 1956 to 1990. 1990 to 2002 is a little bit more of a hybrid model of industrial development. You have a few large firms, some of whom were actually started during that 1956 to 1990 period, who were then endowed with quite a bit of state funding that they could then use somewhat at their own discretion, but they were encouraged to use that funding to create joint ventures with leading international firms and indigenize some of that technology from those international firms within China and create a few different operating models in the process. So notable joint ventures during the 1990 to 2002 period were with like Nortel in Canada, Philips in the Netherlands, NEC in Japan. And these were all successful insofar as the joint ventures were established and they did actually become functioning. But what the Chinese government had hoped for, which was tech transfer derived from these joint ventures, did not happen. And the marquee projects of this time period, Project 908 and Project 909, were failures in that regard. They spent quite a bit of money, and the outcomes that were hoped for by the Chinese government just were not realized.
How much special attention was semiconductors getting in these two periods compared with other industries?
Yeah, that's really the million or billion dollar question, right? I think the reality is the Chinese government understood that chips were important, and as a result, chips were included in a lot of their more general industrial plans, the 5-year plans, the science and technology roadmap plans. But there were very few standalone industrial plans which called out the chip industry and encouraged its accelerated development, and then also endowed Chinese firms with the funds to really pursue that goal. And that actually is a nice segue into what changed in the following periods from 2002 to 2014, and then 2014 to present, in that the Chinese government explicitly started focusing on the development of the chip industry. And of course, this was a very easy target for them to recognize because they had really never had the domestic production needed to satisfy their domestic demand in terms of chips. So by 2002, this was a severe deficit in regard to their ability to produce domestic chips. And in practice, it just meant the government started focusing explicitly on the industry, and they went after the leading edge pretty much out of the gate from 2002 to present. And the way they did that was by actually copying a production model in the industry known as the foundry business, in which you're just a contract manufacturer. You don't do any design, you don't do assembly, test, or packaging. You work with both sides of that equation, but your sole purpose in life is just fabricating chips in class 1 clean rooms, in big factories that require really expensive equipment. And it's the most capital intensive part of the overall chip fabrication process, but it's also obviously the most important, because if you can't physically make the chips, all the good designs in the world and all the testing and packaging in the world don't really matter. And the way they did that was by focusing funds on a few national champions, namely Semiconductor Manufacturing International Corporation, or SMIC, and trying to poach engineers from countries that already had existing programs or chip programs that were particularly well regarded. So this would be South Korea, Taiwan, Japan, the United States, and a few countries in Europe that really were leading then and continue to lead to this day in many respects. And the outcome of these efforts was actually, again, not really the success that Beijing had hoped for, because SMIC, while it did pursue somewhat of a fast follower strategy, and it did start to have manufacturing successes that were, let's say, 3 to 5 years behind the industry's leading edge, SMIC never really caught up to the leading edge. And this was something that, with the benefit of hindsight, is not too surprising. They just simply didn't benefit from having the best engineering talent in the industry, the best equipment in the industry, and the best process manufacturing know-how in the industry. And those are all essential if you're actually going to play with the big boys in this industry.
Before we get to the most recent phase of this, can you talk a little bit about the challenge as well as the rewards one reaps from being at the leading edge?
Yeah, absolutely. So the most obvious reward that you reap by being at the leading edge is you essentially are guaranteed that whatever you are producing is going to have demand, because consumer electronics firms always want the latest and greatest chips for their desired performance properties. And an easy example of this is something like the Apple Watch, which requires a very small but very powerful chip. And it's going to be the most advanced chip in the world on any given year, simply because Apple can afford to pay the premium price for it. And on the flip side, Apple's primary contract manufacturer, TSMC, loves making those leading edge chips because they know they have a customer. And it's really easy for them to forecast demand for something that is the latest and greatest because they know Apple's going to want it. So that's the main benefit. The downside of it is the story of Intel more generally, which is if you mess up at the leading edge, your mistakes are going to be tremendously costly and take years to fix. And essentially, if you mess up at the leading edge, you have dug yourself a hole that is nearly impossible to get back out of, because your capex in this industry to get to the leading edge is tens of billions of dollars annually, and then on top of that, you need an R&D budget, which is probably for 5 to 10 years preceding you developing a leading edge chip, 20% of your profits annually. So you're just burning cash. And if it doesn't pay off, it's a really catastrophic failure from a financial perspective. And that's what's happened to Intel in the last couple of years, which is, of course, very unfortunate. And we can get into that later. But those are the top level benefits and trade-offs of pursuing leading edge manufacturing in this industry.
As someone whose spouse just got a new M1 MacBook Air, I can concur that leading edge is really something. John, so there's something qualitatively different about spending 20% of your profits, putting tens of billions of dollars into this R&D stuff, and doing a fast follower approach, which is, 3, 5, 10 years behind what the TSMCs and back in the day, the Intels of the world were able to produce.
Yeah, absolutely. And it's a little bit deflating from a policymaker perspective to have thrown such massive sums of money at a company like SMIC, and 20 years after really starting to open the spigot in terms of funds, not have a leading edge manufacturer in the country to show for it. That has to be a little bit disappointing. But this is not exclusively the fault of either SMIC or the Chinese government or a failure of imagination. They had their goal. It was well articulated. At the end of the day, it really speaks more to the fact that the industry is difficult to break into. It takes a lot of time. And if we're having this conversation 20 years from now, that SMIC may well be at the leading edge, and a 40-year time horizon to develop a leading edge chip industry is probably about right. If it had happened within a 20-year period, this would be the sort of case study that Harvard Business School would eat up. It would be a pleasant surprise. And that's just the reality. And to be honest, the Chinese government's well aware of that. So they're committed for the long haul anyways.
Do you want to do the post-2014 plan, or have we covered it?
Sure, yeah.
So briefly, what changed after 2014?
Yeah, so in 2014 and 2015, the Chinese government really got serious about the chip industry in particular. And this was evidenced in 2 industrial plans that came out during that time period. First, in 2014, the National Integrated Circuit Plan and the corresponding National Integrated Circuit Fund were stood up. And these articulated big picture goals, 10, 25-year time horizons for where they wanted the Chinese industry to go, what they wanted the Chinese industry to make, and how they hoped that the industry would get there. And then in 2015, of course, Made in China 2025 was released, and chips were one of the 10 or 12 industries that were highlighted in Made in China 2025, but they got another very explicit call out. And there was also a corresponding technological development roadmap that they released with production targets, which were very ambitious. And we can get into this later, but there's just no way those production targets are going to be met on the timeline they hoped for. So, for example, they said that 40% of all chips that China consumes in 2020 should be made in China. And that didn't happen. And also, it was a somewhat poorly defined goal because they didn't do a great job defining what constitutes a made in China chip. But that is a little bit more of a detailed conversation. The big picture takeaway, though, is they started focusing much more deliberately on the development of the chip industry and investing up and down the chip industry's global value chain outside of China to indigenize production within the country and kind of best practices worldwide in country, and then also within China, and fostering a very vibrant chip design sector. And they've already had a very successful semiconductor materials industry within the country, but really shoring up that global value chain as well.
So we're halfway through the Made in China 2025 class. What does the midterm report card say?
Yeah.
And you can't say incomplete. I'm sorry.
Yeah, I won't limit myself to that. So the midterm report card isn't great. And the reason we can say that with some level of confidence is because the chip industry is very well structured, and there's a wealth of publicly available data out there that if you know how to interpret this data, you can basically tell the future of how a specific factory or a specific country's series of factories are doing in terms of their production, their output, or their timeline for development and full production. And when you look at the data and you look at what China has done and is doing and will do in this period from 2015 to 2025, they're just going to miss almost all of the production goals that they articulated in 2015 for both the 2020 period and the 2025 period. So they hoped that by 2025, China would be producing 70% of the chips that China is consuming in 2025. And depending on how you define Chinese chip production, you can either define it as a Chinese headquartered manufacturer that is operating a factory in China. That would be like SMIC, for example. Or you could define it as any company, international headquartered or Chinese headquartered, that is producing a chip within China. The report card just doesn't look good either way. In 2020, we're producing under 10% of the chips China needed. If you count it based purely on Chinese headquartered chip companies, and if you include the non-Chinese headquartered chip companies that happen to have a factory in China, so this would be output from Samsung's factory in Xi'an or Intel's factory in Dalian or SK Hynix, even then, they're still under 20%. They're just a long ways away from making 70% of their chips that they consume in China in the next 4 years. And you can look at factory build times and the number of wafer fabs that are under construction currently and what the lead time is to order specialized pieces of equipment. In some cases, it can be 18 months to 2 years. And then the time required to get that equipment up and running, get your process flow dialed in, and then actually get wafers and throughput up to the point where you're getting the commercial yields that you expect. The timeline it's well beyond 2025 for basically all of the factories that they've started in the last 5+ years. The big exception being YMTC, which is honest to God producing memory chips in China, and they're doing it at volume production. So good for them. They made it.
So how does the Chinese government strategy differ from the likes of Taiwan and Korea and Japan when they were in the early stages of building up their own semiconductor industries?
Yeah, great question. The first thing that I should say is the one thing they all have in common is everyone benefits from tremendous amounts of government support. So what China is doing is perhaps unprecedented in terms of the scale and the volume of money involved, but it does not differ in conception from what Japan, Taiwan, and South Korea did when they wanted to really develop their chip industries. I'll start with Japan, but what Japan did was they got lucky in terms of their timing. They focused on a subsector of the industry, the memory chip industry, and they used their targeted investments to dominate in the memory chip side of things. And the memory chip business is very cyclical. What happens is there is perceived demand for memory chips. The memory chip makers produce a ton of memory chips. They almost always oversupply the market. Then demand gets depressed. The memory chip companies run into a rough 18 months to 2 years of time for them financially. And then demand kicks in again and they make more chips and the good times come back. And what Japan did there is they got lucky in terms of their timing. They started really funding their memory chip businesses at a downturn in the industry internationally. And that was really great for Japanese firms to then enter when there was an upswing in demand because they could really start marketing their products in an environment where those products were desirable outside of Japan, which is an essential part of being successful in the chip industry writ large. No country is an island with respect to this business. You have to sell outside your country if you are going to get the economies of scale necessary to actually have a commercially viable business. There's even China, which consumes more chips than any country in the world. For a Chinese firm to be successful, they need to be able to sell outside of China. But that's a brief digression. So Japan got lucky, and they also targeted a subsector of the industry. Taiwan did a similar thing. So again, lots of government support, specifically in the form of the Industrial Technology Research Institute and a few of the other science parks, which the government stood up. And these science parks were basically places that had preferable tax rates if you housed your business in them. They were free trade zones, or they had access to free trade zones, so you could avoid some of the friction that comes with international trade customs and duties. And they encouraged returnees. So a lot of the Taiwanese industry was and is led by Taiwanese engineers who worked overseas for a long period of time. Worked in the US, they worked in Europe, some of them worked in Japan. But the greatest success the Taiwanese industry has seen has been with these returnee engineers who then go on to take over or found marquee businesses. And the most marquee business in Taiwan right now, of course, is Taiwan Semiconductor Manufacturing Company or Corporation, TSMC. And there's been plenty of talk on this podcast and others, I'm sure, about TSMC. But the key point to take away from Taiwan's success is what TSMC does and what UMC, they're less known, but also a very proficient partner in the country. What they do better than anyone else is contract manufacturing. So again, like Japan focused in memory, Taiwan focused in contract manufacturing or foundry services. And that was key to their success. Finally, South Korea synthesized some of the lessons of Japan and Taiwan. And really, South Korea is the most recent entrant into the industry in terms of an internationally competitive firm, at an internationally competitive firm level. The South Korean chip industry did not exist in a pure fabrication sense until the 1980s, certainly, but really the 1990s is when it started to take off. And the reason it took off was, again, South Korean government support. There were pretty aggressive tariff reductions, preferred interest rates, subsidies for research and development, and some pre-competitive research that they sponsored. But also the competition between chaebols in South Korea and the big industrial conglomerates, all of which had internal chip divisions, which were making products that were designed to be incorporated in other divisions of these conglomerates. That structure of business enabled some pretty quick internal feedback loops. So if, for example, SK Hynix was making a memory chip or an automotive chip, like a power semiconductor, and they wanted to put it in their Hyundai vehicles, they would put it over to the automotive division, having fabricated it in the chip division. It would either work or it wouldn't work. You would get feedback much faster, and you would get unfiltered feedback loops in that you would get the honest feedback and in a way that allowed the chip engineers to incorporate it quickly and strategically and do better.
And so what lessons are the Chinese learning and not learning from those experiences?
The lessons the Chinese government has taken from these experiences are definitely that it pays to focus on subsectors. And the Chinese government has definitely focused on foundries and memory chips. And that's probably a good place to start. Memory chips are, quote unquote, the easiest of the chips to make. And that's being generous. Memory chips are not easy to make, but they are, compared with analog semiconductors or CPUs, they're much easier. And they correctly focused on that. And they also focused on foundry services and giving money to companies like SMIC so that they could upgrade their process technologies by buying really good internationally made manufacturing equipment. And they've done an okay job of getting out of the way of the companies. So another thing that Japan, Taiwan, and South Korea did that the Chinese government observed is at a certain point, the economies of scale that I referred to earlier are essential for private firms to succeed. And the Chinese government has, compared with other industries that they are trying to support, had a somewhat light touch. So there may be some listeners who roll their eyes when they hear that, but compared to, I don't know, the agriculture sector or something, the chip industry in China is a little bit more market driven. And the Chinese government definitely learned that lesson, both iteratively through trial and error, and also by observing what was successful with Japan and Taiwan and South Korea's efforts.
So one of the things you write about that's holding this industry back is strategic fund allocation, and that, while being somewhat in line with your kind of idealized vision of the path the Chinese government should go down, doesn't quite always line up to putting your bets always in the right spot. So where is the break in the system from a strategic and fund allocation side, setting the human capital issues and worries around U.S. exports controls aside?
That great Chinese idiom, heaven is high and the emperor is far away, is really true in this industry as well, in that there are just a lot of regional, local, sub-national funds that have been stood up with money, sometimes allocated from the central government, but they are spending it frivolously. And the downside of that is government doesn't have perfect insight into what some of these funds are choosing to invest in. And conversely, some of these more local or subnational funds are investing in things that maybe they should not. And their money could perhaps benefit from a little bit of more central guidance, or at least a little bit better information that the central government might have access to. But the general problem with the strategic fund allocation in China is it is dominated by technocrats who have a vision for what they want. And that vision is pretty focused on making sure there is leading edge manufacturing in China. But at the end of the day, all the money in the world won't get them there. And prioritizing more fabs that are saying they're pursuing leading edge manufacturing really does not represent a good use of funds. What the Chinese government should be doing with their many billions of dollars that they're throwing at this industry is absolutely dominating in things like silicon wafers and neon gas production and photoresist manufacturing, that sort of thing, because those are choke points that let's say China has 75% of the market in some of those areas. That's not true in photoresist, by the way. Japan has 90% market share there. But that's exactly the sort of thing that they could catch up on. And there are plenty of Chinese firms that have vast expertise in chemical manufacturing, and that would be very advantageous for the country and for this industry to have that strategic resource.
Yeah, it's interesting because I can totally see how the sort of sexier pitch that's going to bring you the tens and sometimes even hundreds of billions of dollars into this is saying we want to compete with the best and beat TSMC at their own game and what have you. But the sort of more subtle and arguably smarter long-term play would be to develop those sorts of choke points so that you as a country have leverage that you can use in when you get in these tits for tats with the US that's a little more high end than saying, okay, we'll just stop sending you rare earths or something.
Yeah, exactly. And that tension is very manifest in SMIC specifically. There's been some great coverage in the Financial Times of all places for the last few years about the internal conversations happening at SMIC and the debate about whether it would be wiser for them to focus on really dominating at 22 and 14 nanometers and dialing in that process manufacturing, which is incredibly lucrative and very profitable, but it's also not the leading edge. And that is where the tension is there are also voices, many of them aligned with the Chinese government, which are telling SMIC that they have to pursue the leading edge. And it's okay if they're not great at 22 and 14, so long as they're pursuing 7 and 5. So trade-offs abound.
Yeah. And then the question is, to what extent is that money that's getting thrown at 7 and 5 money that's wasted, or is it a sort of investment in the future of that 27-year-old engineer who's working in SMIC, who, if they were sticking with the 22 nanometer stuff, they would never be able to make a shot at this later on in their career. And by putting money into the fancier, harder end of this spectrum, you're building a more competitive ecosystem for the long run, even if you're trading off the kind of leverage you may get in the 5-year time horizon by having a tighter grip on some less advanced technology.
Yeah, definitely. Pursuing leading edge is great from a marketing perspective because it allows you to both recruit and retain good engineering talent. So you're going to keep Chinese engineers in the country that would have otherwise gone overseas to work at the leading edge firms if they have a leading edge firm in the country they can work for. And also you can probably poach some Taiwanese engineers that are working at TSMC or some folks from South Korea or Japan that are working leading edge stuff in their respective countries to come to China with the promise that they get to do the latest and greatest stuff.
Gotcha. So let's turn now to the U.S. response. After leaving government, John, it seems like you have caught the Substack bug. Your Substack at semiliterate.substack.com is fantastic. You've been writing a number of posts looking at the developments in the U.S. policy sphere around these issues, and I want to talk you through some of them. So first off, the CHIPS Act. What is it? What does it get? And what's it missing out on?
Yeah, absolutely. Thanks for the kind words. Semi-literate is really just a play on words because obviously I'm not an electrical engineer, so I'm only semi-literate with respect to this industry. The CHIPS Act is really interesting, and it's definitely the biggest effort by the U.S. government to support the domestic U.S. chip industry since consortium called Semitech was stood up in the late 1980s. So the CHIPS Act passed in January 2021 as part of the National Defense Authorization Act, which is the big annual bill that Congress passes that funds all of the defense priorities for the United States. And it's basically must-pass legislation. So anything that gets included as part of the NDAA automatically has a very good chance of becoming law. And this is what happened with the CHIPS Act. It was actually introduced last June or July, and it wasn't clear if it was going to get a standalone vote or not, but it ultimately became law through the NDAA. And as a result, it has a little bit more of a DoD focus than the original CHIPS Act, the standalone CHIPS Act had. But it takes a two-track approach here, where the U.S. government wants to both promote existing manufacturing capabilities in the U.S. and expand on those and expand on it in new directions for manufacturing capabilities, both for conventional semiconductors and also incentivizing research and development, which will, they hope, result in new chip architectures, innovative techniques for fabrication, a whole lot of advances that the industry is eager to realize now that Moore's Law is coming to an end. And in practice, what this means is the U.S. government is very focused on made in the USA chips and making more chips in the USA, which is going to be great if you're a large chip maker like Intel or an equipment maker like Applied Materials or Lam Research. And it's going to be less helpful if you are a little startup in Silicon Valley that has the dream of photonic chips and you really love the idea of manipulating light to communicate and store information and believe that is the future of the chip industry. But as with all big pieces of legislation, the devil is in the details. This could all come to pass, and it could be both a great act that sustains the current model that has made the U.S. industry so competitive and also incentivizes innovation, which makes the industry competitive for 50 more years. It'll just depend on how the implementing agencies take Congress's intent and run with it. But my critiques of the act were, very much focused on that underemphasis on innovation. It called for a lot of redundant reports. There have been like 25 reports sponsored by the U.S. government in one form or another, either through a third-party contractor or directly by a U.S. government agency, all about pretty much every facet of the chip industry. Congress, for all of its pluses and minuses, definitely doesn't hire a lot of PhD electrical engineers, so there was some technical roadmap detail that was lacking. And the single biggest issue that's facing this industry relates to workforce and the ability to recruit and retain talented engineers from physics, chemistry, and the electrical engineering fields who want to work in chips for their careers. And for the most part, the act sidestepped those issues. So those were the big picture critiques.
My favorite is the DNA chip. Have you seen this?
Yeah, I've heard of this. I haven't seen it, but it's like an alternative form of compute, like biological compute or something, right?
Yeah, it's the future. And what a shame Congress isn't on board.
Not yet. Maybe some other agency will get it.
Not yet. Give it the DNA chip lobby is 5 PhDs out at Stanford. It doesn't quite have the heft of an Intel, sadly, but they'll get there.
Not yet.
John, you want to riff on the Labs Not Fabs theme?
Do note that we recorded this a few weeks ago before Intel's new strategy announcement.
Sure, yeah. In brief, the Labs Not Fabs thing is basically the fact that what we're observing writ large in the chip industry is a slow motion crisis. Moore's Law is coming to an end, and in practice, what that means is the operating model in the chip industry, which has governed a firm's success or failure for the last 60, 75 years, which is cramming more transistors on smaller pieces of silicon, is coming to an end. So we are reaching the atomic limits of what we can do with traditional transistors and gates on silicon. And we need to come up with something else to communicate and store information that we have used chips for in the past. The best way to do that is going to be over-investing in research labs. And the US government has world-class research labs that are part of the Department of Energy, and some of them people know by name, like Los Alamos, and some of them people have never heard of, like Oak Ridge. But the punchline is the US government has these facilities that are centers of excellence. There are like 10 or 12 or 14 of them in the US, and they're filled with very smart engineers who love hard science and are very motivated to do innovative research. And the CHIPS Act could have thrown a lot more money at those labs, and that would have been money very well spent, because by focusing on fabs more than labs, what you end up doing is basically encouraging the chip industry to pursue its traditional operating model to the bitter end. And there are lots of creative ways that you can get around the slowdown or perceived end of Moore's law. They're doing things with packaging and chip stacking, and the term nanometer doesn't actually refer to the performance characteristics of a chip anymore. Like Intel's 10 nanometer chip performs at about the same level that TSMC's 7 nanometer chip does. So there's a little bit of variance here in how far away we are from the end of Moore's law. But the fact of the matter is that by focusing on funding existing fabrication of quote unquote normal silicon CMOS chips, you're not going to innovate the way that we ultimately will need to innovate to dominate going forward.
John, how many degrees away is Intel from turning into a sclerotic SMIC SOE national champion?
Oh man, hopefully many degrees away. It's been a really rough couple of years for Intel. So on the one hand, the thing that's made Intel so successful is it has this instruction set architecture called x86, which forms the bedrock of all CPU design. And CPUs are just the brains of computers. Think of memory chips as the chips that remember things, and CPUs as the chips that actually execute instructions and compute for your computer. They are the essential part of what makes our electronic devices think and work for us. And Intel's just had a complete monopoly on that, like 95% of the market, because of inventions that the company made decades ago now, and has dominated in the personal computer market in particular, and took advantage of that ascendant wave into the 80s, 90s, and early 2000s. But Intel's gotten unlucky in that smartphones became a thing, and the CPUs that they design they run hot and they burn a lot of energy, and those are not great characteristics for a smartphone where you have a small battery and it's in your pocket. And those macro factors haven't helped into Intel's business. At the same time, to go back to what we were talking about earlier, they had a process slip last year, so their fabrication technology more generally has not continued to progress at the rate that they had hoped for. And that process slip is going to cost the company probably double-digit billions over time. It isn't clear quite yet what will happen. And they actually just fired their old CEO, Bob Swan, and hired an Intel veteran who had been over at VMware recently. And I believe he's taking over like this or next week. And he's an engineer's engineer, apparently, and they're really optimistic that he'll be able to turn around the company. And it'll be a bit like the story of Steve Jobs and how he built up Apple, and then he left and Apple stumbled, and then he came back and he released the iPhone and changed the world. And they're hoping that's what will happen with Intel. To get to your specific question, I don't think it will end up like SMIC simply because it has a huge intellectual property moat. Like where Intel's headed is in the direction of IBM, which used to be innovative and brilliant and come up with all sorts of novel things that really revolutionized the way people go through their daily lives. And IBM is still around. It's still a big company. It still has the most patents of, this was true a few years ago. I don't know if it's still true, but they still had the most new patents registered year on year of any company. So they're doing things, but their business has transitioned from designing and making world-changing devices to coming up with technologies and charging other companies to license them, and then letting those companies do world-changing things with those with the licensed technology. That would be where I worry Intel is headed. And we'll know more, I would say, by later this year, because one thing the CHIPS Act could do is throw up to $3 billion at a company like Intel and incentivize them to retool one of their existing factories and upgrade their ability to produce the next generation of chips. Or it could give them money to buy more advanced equipment, a little bit of both. We will see if Intel takes that sort of money. And if it does, that to me would be a sign that it's admitting that it needs money and that pursuing purely commercial electronics isn't enough for it anymore. And that would be a level of state support, tangential state support, that Intel hasn't had to rely on previously. Also, $3 billion actually isn't that much money for a company like Intel, so we'll see how much it moves the needle.
I was about to say, this act is not going to have a lot of impact one way or the other.
Yeah, it'll be really good for defense microelectronics. That's one thing I forgot to mention, is the program that the U.S. government uses to purchase microelectronics is called the Trusted Foundry Program. It was stood up like 20 odd years ago during the Bush administration. And essentially what that did is it looked for companies capable of making chips in the US, and it asked them if they were interested in doing or expanding their business with the US government. And then it defined criteria, which if a company were to meet those criteria, they were quote unquote trusted, and thus their chips could be trusted and they could go into defense systems. But the problem with that, and this has become a reoccurring theme now, I guess, in my comments, is the defense industry, or DoD alone, is not enough to support any chip company, in the same way that only selling to other Chinese buyers is not going to be enough for a Chinese chip company. You really need to have a broad focus in order to have the scale of commercialization that gets you the economies of scale that make you competitive. And the reforms to the defense microelectronics side of things will be good. They're probably a little overdue, and we can talk about global foundries and how that fits into the CHIPS Act and it being a little overdue too, if you want. But yeah, these big manufacturers in the US like Intel and Global Foundries all could use some money and some help. It's just that from the perspective of an outsider who is interested in seeing the U.S. chip industry remain competitive for the next 50 years rather than the next 15 years, the focus on companies like Intel and Global Foundries that we see in the CHIPS Act is okay, but it's not really what we need long term. And we just need to see a lot more innovation that will probably come from smaller startups and later entrants than companies like those.
So let's come back to our favorite theme here at China Talk, export controls. What is your take on what the U.S. should be doing with them?
Yeah, complicated question. So export controls on chips and chip-related things to China are, of course, a hot button issue. I think in general, what the U.S. government has done so far with respect to export controls on the semiconductor industry, it probably has not hurt the U.S. industry as much as I had worried, and it probably has not hurt the Chinese chip industry as much as the U.S. government had hoped. So I guess my personal view is somewhere between the two ends of the spectrum. On the one hand, there are people who think that the status quo is just fine and we don't need to worry about selling chips or semiconductor equipment or EDA tools to China. And then on the other end of the spectrum are people who are like, we cannot have Cadence, Mentor, or Synopsys sell any EDA tools to any Chinese buyer. And I'm obviously somewhere in the middle, as I think most people who have engaged with the industry are. It's just impossible to cut China out of the global value chain at this point. And if you really wanted to, what would end up happening is you would bankrupt semiconductor manufacturing equipment makers and EDA tool vendors in the US two of the crown jewels of the US chip industry. And in the process, you might not bankrupt them. That might be a little hyperbolic. But what you would do is you would severely curtail their ability to invest 15 to 20% of their annual revenue in research and development. And that research and development is what has made them crown jewels. I think broad strokes, my preferred path would be something like no lithography, etch, metrology, process control equipment can be sold to a Chinese end user that is attempting to use it for sub 7 nanometer or below manufacturing, let's say. And I think that would probably also that's probably okay with EDA tools as well. But EDA tools they're just software. And they've probably already been licensed at least to HiSilicon in China to do 7 nanometer chips before the Huawei sanctions went into effect last year. So the cat's out of the bag there. And if they really wanted to, and I'm not saying that they already have necessarily, but it would be a very simple matter to copy that software, and it's already in China. So the problem with doing that is if you're a Chinese firm and you pirate EDA software and you then use that pirated EDA software to design a chip, which then gets fabricated by a Chinese firm, you have broken many international agreements, and not the least World Trade Organization obligations and World Intellectual Property Organization obligations. And so that chip could never be sold outside of China to a buyer. And even if it were sold to another buyer in China, both the producer and the consumer of that chip would probably be targeted by the government, the EDA tool vendors that's displeased with that outcome.
Speaking of all the things that the U.S. government could spend billions of dollars on to support U.S. semiconductor policy, one of the very impressive works of bringing a ton of different data sources together by CSET was putting a number around how much money these different parts of the global supply chain would lose if they stopped doing business with China. And at different points in the supply chain, you have different amounts ranging from $20 million all the way up to $1 billion for some of the chunkier ones. I'm curious, John, for your thoughts on the idea of compensating these firms for the losses that they would incur by having to stop licensing or selling their technology to China.
Yeah, I like the idea on the face of it. I'm sure there are some WTO subsidy agreement problems that would need to be worked out, and you probably
it's 2021. Come on, WTO, like we can.
That's true. Yes.
Setting that aside.
Yeah. In general, it makes good sense to me, and the fact of the matter is the amount of money that some of these firms would lose by only having a small part of their overall sales to China curtailed is not so large that the U.S. government could not offset it. The bigger picture problem down the road would be the Chinese government's paranoia that sales from the U.S. vendor to Chinese buyers would potentially be impacted going up the ladder of nanometers down the road. And they would probably end up trying to design out U.S. suppliers. And so in the short term, compensating these U.S. vendors of equipment or EDA tools makes good sense, and you could probably offset it. But the Chinese government would look at that as it would be a bellwether for them. They would be quite concerned, and they would come up with some workarounds that would make sure the Chinese industry wouldn't have to rely on the U.S. as much as it had been previously. Of course, that reliance being incredibly lucrative for the U.S. industry.
But John, hasn't that Rubicon already been crossed?
Yeah, that is the comeback. And yes, to be clear, the Chinese government probably has internalized with some of the export control actions and sanctions of the last few years that decoupling in the chip industry more generally is desirable, and they're doing things to accelerate that. But they still are going to run into the fact that many subsectors of the chip industry are an oligopoly, and they cannot make chips without relying on U.S. inputs at this point. And I think to ban sales of specific nanometer chips and that sort of thing would further incentivize them away from it in a way that would be very damaging for U.S. firms, and that those U.S. firms could itemize. So I guess this is a nice segue to then bringing up the other part of what my desired export control policy on chip-related items to China would be, which is a plurilateral agreement where China doesn't have any other buyers to turn to. So Japan and the Netherlands, who are really the other countries that could benefit from, who have companies in their countries who could benefit from unilateral U.S. controls, which would cut off the ability of U.S. firms only to sell to China. If the U.S. can get Japan and the Netherlands on board, then I think this is totally the way to go. But barring that, I'm very cautious because if you look at the comments submitted by a company like KLA or Teradyne in response to the BIS Foundational Technologies rule, they itemize the amount of sales that they lost following the export control actions on Huawei to competitor firms. And of course, their main competitor firms are, again, coming from Japan, the Netherlands, probably Germany, and maybe a few other countries. But that's trade diversion in action, and that's what happens with unilateral export controls on something that has widespread foreign availability. So U.S. government policy has to be responsive to that foreign availability.
The other question I have is like focusing these export controls on the high end means that you may end up pushing the Chinese government into a strategy which they should have been doing all along, which is trying to focus on that 18, 22 nanometer strategy, which earlier in this podcast we talked about was potentially a more effective way for them to go out building this.
Yes, absolutely. I think the greatest resource that the Chinese government could have right now is a Chinese foundry that was producing wafers with a yield over 90% for something below 22 nanometers. And they just don't have that right now after lots and lots of time trying. And there may be exceptions to this. There probably are some lines at SMIC which are below 22 nanometers and above 90% yield on their wafers, but the volume is lacking. They can do it, but they can't do it at the scale needed to meet the demand. And that really is probably where the Chinese government should have been focused for the last 5 or so years, 10, probably longer than that. But instead, they've really wanted to be wherever the leading edge is. And that now we are seeing the cost of that.
So, John, Doug Fuller, a previous China Talk guest, has an argument in a recent paper which basically says that the U.S. government doesn't really have the capacity to do the sort of export control strategy you were laying out of being subtle and making calls on the edge that sort of thread the needle. What's your thought on this as someone who's been on the other side of things?
Yeah, Doug's point is a good one. The two things that come to mind immediately are, first, the median wage in the chip industry is like $160,000 a year. So going to work in Washington, D.C. as an electrical engineer, your opportunity cost is quite high. And regulating the industry that you have a PhD in, that you could be working in, it's a real opportunity cost, both financially and professionally. And that means in practice that the regulatory agencies that govern export controls just don't have access to the level of technical expertise that you might hope for. And then conversely, the other point is an agency like BIS isn't necessarily a perfect example of regulatory capture, but because they don't have that level of technical expertise, they do rely on industry quite a bit for informative input when it comes to decisions. And it cuts both ways. It's both a valuable service and the public comment process that BIS has, you can look at every public comment that's submitted in response to a proposed agency action, and you'll see it's a lot of big corporations that are registering their concerns and submitting suggestions, and it's all on the public record. So it's very informative, but at the end of the day, the government has to be able to close the doors and make decisions. And I think Doug Fuller probably has a point when he says that there's a little bit of technical acumen lacking, and structuring these export controls in a way that threads the needle between targeting China or Chinese firms or Chinese end users without destroying parts of what makes the U.S. industry competitive is beyond the depth of technical talent. So that's not the nicest thing to say about a former employer, but I didn't really work on any export control stuff at BIS. I just did assessments and surveys. So no broken eggshells to step on.
John Verwey, thanks